video on factors and multiples, we used tests of divisibility and long division to determine the factors of a given number, right? For example, if you want to list the factors of 8, you will have it by 1, 2, 4, and 8. You can see here that only 2 is a prime number. 8 is a composite number and 4 is also a composite number. Only 2 is a prime number here. What if you wanted to write 8 as a product of prime factors? These are the factors. 1 is a factor of 8, 2 is a factor of 8, 4 is a factor of 8, and 8 is also a factor of 8. Here you have listed the factors of 8. But what if you wanted to find 8 as a product of prime factors? Let's say if you want to write 8 as a product of prime factors, then you will start to make your tree like this. Since 8 is an even number, it is divisible by 2. Here we can do 2 times 4 is 8. 2 times 4 is 8. Here you can see that 2 is a prime number, but 4 is not a prime number. 4 is a composite number and 2 is a prime number. 2 is a prime number and 4 is still a composite number. Now what you will do is you will copy the number 2 as it is, and then you will express 4 as a product of prime factors. 2 times 2 is 4, and you will copy the multiplication sign over here also. Here you can see that since 2 is a prime factor, in the second stage you have reached all the prime factors. If you want to express 8 as a product of prime factors, you will write 8 is equals to 2 times 2 times 2. 2 times 2 is 4 and 4 times 2 is 8. This is the final answer. Let's look at another example. Let's express 36 as a product of prime factors. Let's make 2 branches. Since 36 is an even number, it is divisible by 2. If you divide 36 by 2, you will get 2 times 1 is 2, 3 minus 2 is 1, you will copy 6. 2 times 8 is 16, 0 and 0. 2 times 18 is 36. Here 2 is a prime number, but 18 is not a prime number. You will branch 18 out. This will be copied as it is. Then you will branch the number 18. Again, 18 is an even number. So 2 times 9 is 18. Now, in the second step, we have 2 prime numbers. 2 is a prime number and 2 is a prime number. But 9 is a composite number. Now we will copy 2, multiply by, this 2 will also be copied. Then you will copy multiplication and then you will branch out the number 9. 3 times 3 is 9. 2 is a prime number, 2 is a prime number, 3 is a prime number, and 3 is a prime number. You can write 36 as 2 times 2 times 3 times 3. 36 can be expressed as the product of prime factors. This is called the factor tree. Let's look at another example. Let's express 75 as the product of prime factors using factor tree. You will branch it out. 75 has a unit digit of 5. 75 is divisible by 5. Divide 75 by 5. 75. 5 times 1 is 5. 7 minus 5 is 2. then you will copy 5. Then 5 times 5 is 25. 5 times 15 is 75. 5 is a prime number. You will copy 5 as it is, multiply, and you will branch out 15. 3 times 5 is 15. Here you have 5 as a prime number, 3 is also a prime number, and 5 is also a prime number. You can write 75 as a product of prime factors as 3 times 5 times 5. Notice here that I have written the number 3 first and then number 5. Why? Because it's a general practice to write the smaller number first. We write smaller number and we go up to the larger number. This is the general practice. This concludes the session for prime factorization using factor tree. Thank you so much for watching.